Okay, here we go. Let's zip through the first 5 questions then. Let's get rid of that. So the first question you should instantly recognize as a wordy simultaneous equation question. Let me just find my solution shares to check. Where are they? Okay, so let's read it out. If twice the age of a son is added to the age of the father, the sum is 56. That's equation number 1. So I'm basically saying if twice the age, oops, let me just get that. Twice the age of the son plus the age of the father is equal to 56. That's equation 1. And then equation 2, if twice the age of the father is added to the son, that is equal to 82. So solve for the age of the son and the father. Okay. So it doesn't really matter how you do this. I always usually start with equation 1. And I will say from 1, I'm going to rearrange for f equals 56 minus 2s. And I want to substitute in, well, that's a 2 there, 2. Okay, so if I substitute that in 2, I've got 2, and then 56 minus 2s plus s is equal to 82. So if I expand that out, I've got 112 minus 4s plus s equals 82. That gives me minus 3s is equal to 82 minus 112 is minus 30. I can times both sides by minus 1 to get 3s equals 30, which means that s is equal to 30. So the age of the son is 30. Right? Right. Okay, so to work out f, I just need to substitute this back into either one of these equations. So let's just substitute it back into 1. So f is equal to 56 minus 2 times 30. And that, of course, is equal to, if you just work it out quick, is 36, which you will see is completely ridiculous because the father had this son at the age of 6. So I clearly didn't think about that question very hard. I'm really sorry, but it should serve as an example of how to construct a simultaneous equation scenario from a wordy contextual question. Okay, so please forgive me for that ridiculous scenario, but it should test your algebra, and you should be able to solve it accordingly. Yeah. A couple of you have already sort of raised your eyebrows at that one and had a go at me. Fair enough. Okay. Question 2. This one also caused a bit of trouble because I awarded 8 marks to it. I'm going to go through that now. It wasn't worth 8 marks. You're probably right if you'd said that. We'll discuss that in a second, but let's just read this out here. A chimpanzee has a mass of 55 kilograms. It climbs 12 meters up a tree. How much energy does the chimp use? The change in gravitational potential energy is described by E equals mgh, where m is the mass of the object in kilograms and h is the height, change in height, and g is the Earth's gravitational constant of 9.8 newtons per kilo. Okay, so basically, tree, that's a tree, and the monkey, that's a monkey. Somehow, here's his tail, has climbed from ground level up to a height of 12 meters, sorry. 12 meters, okay. And he weighs 55 kilos. So to calculate the potential energy he has gained, which is exactly the, so the potential energy that's gained must be the energy, must be equal to the energy that he has sort of used up chemically to climb that tree. So how much energy the chimp used, that's the same as the gravitational energy gained. That's simply 55 times 9.8 times by the height, of 12. Okay, everything in there is to two significant figures, so your answer is also expressed, can also be expressed to two significant figures. Just film it. So I actually got 6468 joules, which of course the two sig fig is 6500 joules. Okay. Obviously, you're writing this out, so I would definitely recommend that you draw your marker's attention to how many significant figures you've drawn it, so it makes them realize you thought about it. You could also give it a suitable prefix of 6.5. You could write in standard notation, which would be 6.5 times 10 to the 3 joules, which of course is 6.5 kilojoules. I would accept that as an answer. Oops, a bit fat, isn't it? Either of those is absolutely fine, or that one. Now, that's not worth 8 marks. Okay, now what I've done here is I've cut and pasted something I shouldn't have, and really that's probably worth 4 marks at the most. What I probably would have awarded additional marks for to get the 8, I would have given you a scenario where you might have had to convert units. So I could have given you the mass of the chimpanzee in pounds. I could have given you the height of the tree in feet. And you would have had to have converted into SI units before using this E equals mgh equation to make that calculation. Okay, you obviously get 2 marks for expressing your answer to the correct number of significant figures. Okay, right. So sorry about that. It's caused you an awful lot of upset, these marks. I appreciate that. They will be more fair and obvious, I hope, in the actual exam. Let's move on. Right, question number 3. Okay, so significant figures. So let's just get through these. Let me just scroll up a bit. Right, so I already calculated these, so I'm just going to write them out and explain myself. So for A, if I do this plus this minus this, then I get an answer. If I just sat that into the calculator, something like that, that's 9 recurring, right? Now, get this right. So when you're adding or you're subtracting, you're much more interested in the decimal places rather than the number of significant figures. Okay, so look at the decimal places. Now, the minimum number of decimal places you've got here is the 2. That's an awful color, isn't it? Right. So you can only express your answer to a decimal place of 1. Okay. Oh, hang on, right, I pointed out the 2. It's only got 1 decimal place. That's the best it gets, right? So your answer can only be expressed to 1 decimal place. So that is actually 7.6 to 1 decimal place. But this value is actually to 2 significant figures, right? So to get 2 marks there, you'd have had to write this and then write this. Okay, I hope that makes sense. B, I've been a bit sneaky here. I put a dot after the thousands, and that means that actually that unit there, the final 0, is significant. Oh, what the hell? There you go. Right, so it's actually 4 sig fig to begin with, and I'm subtracting a 3 sig fig value. But again, because I'm subtracting, I'm less interested in the significant figures, and I'm more interested in the number of decimal places there are. Now, there are 0 decimal places, so I must write the answer, whatever it is, with 0 decimal places. Okay, so 1000 minus 95 is just 15, right? Okay, so 15 with 0 decimal places is 2 sig fig again. Okay. Right, so this one is pretty straightforward. I'm just going to multiply 0.06198 by 2.18 times 10 to the minus 3. So the best level of significance there is I got 3 sig fig for this value. And because I'm multiplying, that means my answer's got to be to 3 sig fig as well. So that's the only one I didn't do. Hang on, let me just do that in the calculator. You didn't just see me using my phone as a calculator. I'm using my actual phone, my actual calculator. 0.6198 times. So the answer is 0.01353 significant figures. Let me just check that. I think I missed a 0 out there. It's actually 0.003 135. Okay, 0.00135. So these zeros aren't significant, but these digits are. And you do it to 3 sig fig. Okay, you could also have written that as 1.35 times 10 to the minus 4 to get the marks. Okay, the last one is probably the one that is the most involved. And what you have to do here is you have to consider the numerator and the it's a bit fat in it. Go on, let's change that down. You have to consider the numerator and the denominator separately, right? So you're not going to do any rounding till the very end, but in each case, for the numerator and the denominator, the resultant significance of the ones that are going to carry through to when you actually divide the two, the top and the bottom. Okay. Okay. Let me just do that. If I just do the top bit, numerator, top, and that is, let's write it out again, 4.351 multiplied, plus 105.83. That is equal to, well, again, because I'm adding, I got to consider the decimal places. Now, the best I've got here, I've got 3 decimal places here, and I've only got 2 here. So my answer, whatever it may be, I'm going to express to 2 decimal places. And the answer there is, well, if I just, now this is the tricky bit, right? I don't want to round yet because I haven't finished the calculation. So what I'm going to do is I'm going to write out the full value I get on my calculator, which is actually 6 significant figures. But I'm going to make a mental note that it can only have 2 decimal places. So this will actually be 5 sig fig. Okay, but I'm still going to use the full value in my final calculation. Hope that makes sense. Right, so the denominator, if I can spell, bottom, I'll do the same again, 86.8314 times by 136.94. Now, because this is times, my sort of usual rules apply. And you can see here, rather than consider decimal places, I only want to consider the significance. The best significant figures I've got 1, 2, 3, 4, 5, 6 here, and I got 5 here. So my resultant answer is only going to have 5 significant figures, but I'm going to write up the full answer first and make a note that will be 5 significant figures, right? And then, of course, I've got to divide these two. So I'm going to do that with a mental note that the best significant figures I got between the top and the bottom is both they're both the same. It's 5. So when I do that calculation, I get this 0.009 2. So I've got to express it to 5 significant figures, right? That's as good as it gets. Okay. I'm just going to check that you've done that right on there. Okay, so I've done it wrong because I've given it to 6 significant figures. The answer should actually be 9 to 1, 2, 3, 4, 5. 1, 6. So that should be a 2 on the end there, right? There you go. 92662. Yes, correct. So I'm just reading through your answers, and there seems to be a bit of confusion there. So this is the way to do it. Okay. If you're not sure, then if you go to the tests and exam resources, there is a formative significant figures MCQ test there. You can do this till the cows come home and get the right answer. So if you're really not sure about these kinds of calculations for significant figures, go and practice those, okay? Right, next. Question 4. Calculate the volume of a cylinder with a radius 36 centimeters and a height of 87 centimeters. Express your answer in units of cubic meters and to the correct number of significant figures. The volume of a cylinder is given by this. So I've given you that. And we're going to calculate the volume with 6 marks. So wonder where those 6 come from. Let's do it. So I'm going to give you 2 marks for calculating the volume in centimeters cubed. I'm going to give you 2 marks for calculating the volume in meters cubed. So there's a conversion there. I do say cubic meters. Read the question. And finally, an extra 2 marks are available to you if you can express that to the correct number of significant figures. It's that simple, okay? So get into your head. There are 2 marks available for significant figures. Okay. So pi, basically I'm doing this. Pi times r is 36 squared times the height is 87. I get an answer. Let's write it out. Actually, I'm just going to write it out to the correct number of significant figures. Centimeters cubed. 2 sig fig. Why is it only 2 sig fig? Because this has got 2 and this has got 2. Okay. So that's 2 marks. So I've asked for it in cubic centimeters. So how do I convert centimeters cubed to meters cubed? Okay. Well, 1 centimeters. Okay, I should say 1 meters cubed is equal to 1 million. That's 1 times 10 to the 6 centimeters cubed. Okay. So basically, to get this in units of meters cubed, I've got to divide the whole thing by 10 to the 6. So if I divide, that's 3.5 times 10 to the 5 divided by 10 to the 6, I get 0.35 meters cubed. Do that in your calculator if you're not sure. And because I've expressed it to the correct number of 2 sig figs, I'm going to get the final 2 marks, okay? That's how you get 6 marks for that question. Hope that makes sense. Right, question 5, and then I'm going to have a break. Okay. Right. A train enters a tunnel traveling at 92 miles per hour. Okay, let's write that down. MPH. What else is next? The tunnel is 1.2 meters long. Sorry, 1.2 kilometers long. And the train is made of 6 carriages, 50 meters in length, which means the total length of the train is 6 times 50 meters, which is equal to 300 meters. Okay. How much time elapses between the first carriage, entering the tunnel and the last carriage leaving it? Okay, so let's draw this out. Here's my tunnel. So that's 1.2 kilometers. And here's my train. So basically, my train is sort of 300 meters long. That's a train. It's going into the tunnel at 92 miles an hour. I need to know how long it takes. Like, that's not, if you think about a point on the train here, I don't need to know how long it takes for this to go the length of the tunnel. I want to know how long it takes for the train to enter the tunnel and to exit the tunnel. So basically, the total distance the train is going to travel is the length of the tunnel plus itself. So I'm defining the distance, I'm going to call it S, is equal to 1, let's do it in meters, plus 300 equals 500 meters. Okay. If I just asked how long it took the train to get to the tunnel, then I wouldn't have the extra 300 here. But because I'm asking how much time elapses between the first carriage entering, so there's 6 carriages, 1, 2, 3, 4, 5, 6. It's a really funny looking train, right? 6 carriages, and the last carriage leaving it, I've got to add the total length of the train as well. I hope that makes sense. How do you calculate the time? Well, remember, speed is distance over time. So to get time, that's the same as distance over speed. Okay, and that will all come out in the wash, provided you're going to use SI units, right? Now I'm asking you to work out the time. Let's do it in seconds then, for that reason. Oh, the other problem here is, which is why it's worth 8 miles, is because there's a conversion in here. It's traveling at 92 miles per hour. You're going to need to calculate that, to convert that to meters per second. Let's do that first, right? Convert V into meters per second. Right, how do we do that? Well, you got 92. To convert it into, so that's 92 miles per hour. So to convert miles into meters, I've already given you that a kilometer is 1.61. So 1 mile is 1.6 kilometers, and then to convert kilometers into meters, I've got to times that by another 1,000, because there are 1,000 meters in a kilometer. And to convert hours or per hour to per seconds, I'm going to divide the whole thing by the number of seconds derived in an hour, which is 3,600. Okay, I get an answer, excuse me, of 41. And this is where your extra marks come for your significant figures. How many significant figures are here? Well, the best you can do here is 2. Okay, so that's 41 meters per second to 2 sig fig. Okay, and then to work out the time, I'm going to take it back up here. Remember we did that. The distance is in meters. Oh, that's a 1 there. Sorry, is 1,500 divided by 3,600. Cross off a few zeros, so it's 15 divided by 36. That's 37 seconds to sig fig. Okay, was that question 5? Yep, so I'll have a break and we'll come back and we'll start with those molarity questions. Oh my God, okay, right, how do I stop this? Stop recording.